Greetings everyone, and welcome to this video in my lecture series on binary, octal, and hexadecimal numbers. In this video, we will do a quick review of the decimal system for non-integer numbers. Now, before we begin, if you don't remember what an integer is, we're going to make a note over on the side here. The set of integers is the set of numbers, including the numbers 1, 2, 3, and so on. But it also includes the number 0 and the numbers -1, -2, -3, and so on off to the left. So it's basically the counting numbers 1, 2, 3, the whole numbers, including 0, and also the negative numbers as well. There are no fractional parts, though, for these numbers. So if we look at so let's turn our attention over here to where you can see I've highlighted the number 12.3 in the decimal system. Now, the dot here is called the decimal place. And the first digit to the right of that dot is in the tenths place, meaning that, let's just write that down. The first digit is in the tenths place. So the 3 is actually 3/10, because our decimal system is a positional system where we keep on reusing the same symbols, 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, but where they appear in the number is actually quite important. So I'm just going to scroll up for a little bit and make a note then that the decimal number 12.3 is equal to the integer part of that number, which is 12, plus, and then the 3 is in the tenths place, so it's 3/10. Which means if we move to a different example, that the number 2.345 in the decimal system, then the 3 here is in the tenths place, just as in our previous example, but the 4 is in the hundredths place, and then the 5 here is in the thousandths place. Which means that the number 2.345, let me make that decimal a little bit bigger, is equal to 2 plus 3/10 plus 4 100ths plus 5 1,000ths. And so we can write it in the following way, which will become useful if we're doing converting from other bases. It's 2. And then instead of writing it just as the integer 2, I actually want to write the fact that it's 2 times 10 to the 0, which may not seem that useful, but let me actually write the rest of it. The 3 divided by 10 is the same as 3 times 0.1, which we can also write as 3 times 10 to the -1, plus 4 times 10 to the -2, and then I'm just going to write this on the next line, plus 5 times 10 to the -3. And this representation will become useful when we're converting numbers in different bases back to the decimal system. So thanks for watching, and I hope to see you in the next video.